This is the second example in interpreting and solving matrix equations. Welcome to Numerical Solutions 2C Problems. This time, the problem wants to focus on element 1, 2 from the multiplied matrix LE with a scalar z squared, and this expression is equated to determinant M. Given matrices are 4 by 3 matrix E, 3 by 4 matrix L, and 5 by 5 matrix M. Working on the left side of the equation involving matrices E and L, we are to focus on element 1, 2. And from this notation, take the first row of the first matrix L. Then, multiply this with the second column of the second matrix E. Now that the elements involved are clear, we multiply them. Element 1, 2 of matrix LE is the summation of 0 times 3. 2 times 3, negative 3 times negative 1, and 3 times 5. Simplify this summation to have 24. So the left expression can be written as 24z squared. Moving on to the right side of the equation, where we need to take the determinant of matrix M. The instruction states that the original 5 by 5 matrix should be reduced to 4 by 4 using Cheo's pivotal condensation method, after which the determinant of the matrix will be determined using GBM's rule. With Cheo's pivotal condensation method, a critical condition is to look for a pivot element valued at positive 1. There is this element found at row 2 and column 3. So covering these locations, the partial 4 by 4 matrix arises. With this partial matrix, there should also be negative 1 raised to the summation of the pivot row and column. For this example, that is negative 1 raised to 2 plus 3. To complete the elements, subtract the reflected factors. For element 1, 1, 6 is subtracted by the product of 2 and negative 4, giving 14. Element 2, 1 is subtracted by 2 times negative 1. The next element in the row is subtracted by 2 times 5, resulting to negative 6. Then the last element is 5 minus 2 times 4, giving negative 3. For the second column, 0 on top is subtracted by 2 times negative 4, bringing about 8. The next is negative 2 minus 2 times negative 1, simplified as 0. Then there is 3 minus 2 times 5, which makes negative 13. And lastly, there is 2 minus 2 times 4, making negative 6. The elements in the third column are also subtracted, first by negative 2 times negative 4, which leave negative 5 on top. The next is 4 minus negative 2 times negative 1, giving 2. The third element is 5 minus negative 2 times 5, bringing 15. The last element has 3 minus negative 2 times 4, resulting to 11. The fourth column starts with 5 minus 0 times negative 4, leaving just 5. Next is 3 minus 0 times negative 1, also leaving 3. The following element is also subtracted by 0 times 5, not affecting the element 2. And last is negative 2 minus 0 times 4, bringing negative 2 just the same. The simplified matrix after trios pivotal condensation is then as shown. The scalar of -1 raised to 5 is still around as -1. This scalar needs to be incorporated into the matrix, as we need to work on a different approach later. So place -1 into the matrix, but instead of multiplying all elements by the scalar, -1 should just be placed in one row. If we choose to place the scalar into the first row, the determinant then transforms as shown. A little change in the first row, but all the other elements remain the same. With the transformed 4x4 matrix, we can find the determinant using GBM's rule. This approach requires three partial determinants, where the first one uses the original 4x4. And since this method extends Sarri's rule, mirror the first three columns and work on the diagonals. For the first positive, multiply -14, 0, 15, and -2, which is still 0. The second diagonal is the negative of -8, 2, another 2, and -3, which is simplified as -96. The third diagonal has the positive of elements 5, 3, -6, and another -6, giving 540. For the last diagonal, the elements involved are -5, -1, -13, and -2, making 715. So all positives added together give positive 1159. Next are the negatives. The first anti-diagonal has elements -3, -13, 2, and -5. Multiply together with the preceding negative sign to give positive 390. The second anti-diagonal involves -6, 15, 3, and -14, multiplied into positive 3,780. The following negative includes 11, 2, -1, and -8, resulting to -176 when multiplied. Then, the last anti-diagonal has -2, -6, 0, and 5, multiplied but still gives 0. So all negatives added together give 3,994. Then the first partial determinant M1 is the difference of the positives and negatives, that is 1,159 minus 3,994, making -2,835. The second partial determinant uses the 4x4 matrix, but rotates columns 2, 3, and 4. The second column goes to the end, pushing forward columns 3 and 4. So M2 is taken with the 4x4 matrix just the same. We still use the extended Sarri's rule, so mirror the first three columns and identify diagonals. For the positives, the first diagonal contains elements -14, 2, another 2, and -6, multiplied together to have positive 336. The next set of elements are 5, 3, -13, and -3, multiplied to give -585. The third diagonal has -5, 0, -6, and 11, multiplied to give 0. And the last diagonal has the elements -8, -1, 15, and -2, which results to 240. Adding all positives give -9. For the negatives, work with the elements in the anti-diagonals. The first has the elements -3, 15, 3, and -8, giving -1080 when multiplied. The next anti-diagonal includes 11, 2, 0, and negative 14, which turn out as 0 when multiplied. The third set of negatives include negative 2, negative 13, negative 1, and 5, giving positive 130 after multiplying. The last anti-diagonal works with negative 6 times another negative 6, then 2 and negative 5, which gives the product of negative 360. Now add all negatives and arrive at negative 1310. So for the second partial determinant, take negative 9 minus negative 1310, giving positive 1301 for M2. We are now down to the third partial determinant M3. The matrix used for this is from M2. Similar with what was done with M2, rotate the columns again. So take the second column and move it to the end, pushing the other two in front. With the new 4x4 matrix, apply extended Sarus rule, where we mirror the first three columns once more. For the positives, take the first set as with the elements negative 14, 3, negative 13, and 11, multiplied into positive 6006. The second diagonal has negative of negative 5 times 0 times 15 and negative 3, zeroing out everything. The third diagonal includes negative 8, 2, negative 6, and negative 2. When multiplied, give negative 192. Then for the last diagonal, multiply 5 with negative 1, 2, and negative 6, and proceed it with a negative. The fourth positive is negative 60. When all positives are added together, they result to 5,754. Complete the positives by taking the negatives. The first one of which is negative 3 times 2 times 0 times 5, making everything 0. The second set is negative 2 times negative 13 times 2 times negative 14, giving negative 728. The next negative has elements negative 6, 15, negative 1, and negative 5, resulting to positive 450 when multiplied. The last includes negative 6 with 1, 3, and negative 8, multiplied to 1,584. Take the summation of all negatives and come up with 1,306. Then we can simplify the third partial determinant, which is the difference of 5,754 and 1,306, and that is 4,448. Having completed the three partial determinants, take the determinant of matrix M by their summation, that is, negative 2,835 plus 1,301 and 4,448, resulting to 2,914. Then from the equation, we can deduce that 24z squared is equal to 2,914. Then dividing everything by 24, we get z squared as 121.4167. And z is taken as positive and negative 11.0189.